Hello, Algebra 2 students. I am making this video to replace your Monday whole group on April the 15th because I got called in late on Friday evening I got a call late Friday evening to go to Mobile on Monday and help with makeup ACAP testing. So I will be in Mobile at 6:30 a.m. bright and early on Monday, and I will be there for the entire day, which will probably last till at least 4 or 4:30 in the afternoon. So I will not be able to show up for our Class Connect on Monday at 12:45. So we are right in the middle of Unit 8, and so I thought it was a really good idea to do a lesson on 806 and 807. 806 is finding determinants of matrices, and 807 is finding inverses of matrices. This is a look at what we have on the calendar for the week. Again, we are finishing up Unit 8, and then we are also on Friday. We have day 1 of our 9.01 statistics project, and basically there is a part 1, a part 2, a part 3, and a part 4. Some are mandatory, some are bonus. You'll have to look and see, but they are all worth 25 points. I will be talking a little bit about, maybe not today. No, I'll be doing that soon. I will be talking a little bit about this project on Friday. Don't stress about it. It's not really a project. It's not like a big, long, drawn-out thing. You can do it in probably 20 minutes or less, but it is 25 points, and we need to make sure, and it is a TGA, so we want to make sure that you know how to do that. So be looking for a video or for me to talk about this in Class Connect. Probably I'll do both. I'll probably make a video later this week talking about this 9.01 project, and I will probably also talk about it a week from Monday, which will be April the 22nd. I'll probably talk about it again there. Okay, so we're not going to worry about your choice because we're just going to jump right in. So we got dimensions, numbers of rows by numbers of columns. Just a reminder that when we look at a matrix, we are going to give the dimensions by the number of rows and the number of columns. So this matrix has 2 rows and it has 3 columns. So that's always going to be something important. I did want to review before I got into inverses and determinants. I just wanted to kind of review just a little bit in case you were struggling with some of the earlier sections in Unit 8. So number 1 is an example of a subtraction problem. So when we're adding or subtracting, our dimensions do have to be the same. So both of these matrices have 2 rows and 3 columns. 2 rows and 3 columns. That's the only way we can add and subtract. So to me, adding and subtracting is one of the easiest things that we do in operation of matrices. We just take the numbers that are in the same location. So the 3, we subtract 9, that gives me -6. -1 minus 2 gives me -3. 5 minus -3 gives me 8. Be careful with subtraction. It's like the devil and it will cause you to make mistakes. 0 minus 1 is -1. Almost made a mistake there. 4 minus -5 is 9. And -2 minus 7 is -9. And then I'm a human being and I make mistakes all the time. So I'm just going to go back and check my math. 3 minus 9 is -6. -1 minus 2 is -3. 5 minus -3 is 8. 0 minus 1 is -1. 4 minus -5 is 9. -2 minus 7 is -9. Okay, feel good about that. So that's my answer. So again, we're just reviewing all the way back from the first section in Unit 8. Number 2 is an example of multiplying by a scalar. So this little -5 has a term. It is called a scalar. And when we're multiplying a matrix by a scalar, we just take that number on the outside and we multiply everything in the matrix by the scalar. So we do -5 times 3. Which is going to get us -15. -5 times 7 is going to get us -35. -5 times -1. +5. -5 times 0 is 0. -5 times -2 is 10. -5 times -1 is +5. And then I'm just going to double check because, again, I'm a human being and I do make mistakes. And we'll put our little brackets around that, and that'll be our answer. So again, let's just review. I think multiplying this number 3, I think this is one of the hardest things that we do in Unit 8. So remember, when we're multiplying, we take the first row, always the first row in the first matrix, always times the first column. Always the first row in the first matrix times the first column in the second matrix. Always. It's always row times column. If you don't have the same number of numbers in the row that you do the column, then your multiplication is not defined. Remember, another thing that we can do is we can look at the dimensions. This first matrix is a 3 by 2. This second matrix is a 2 by 2. And remember, these inside dimensions have to be the same for you to be able to multiply. All right, so let's get to multiplying. We're going to do 0 and 5 times -4, -2. So that means 0 times -4 is going to give me 0, always a plus. 5 times -2 is going to give me -10. Then we're going to move on and take that first row and multiply it times the second column. So that's going to be 0 times 4, which is going to give me 0, always a plus. And then 5 times -4 is -20. Then we're finished multiplying with both of these columns. Okay, so we put a little bracket here, and then we move down to the next row in the first column. So we do second row times second column. When we're multiplying with that second row, we're writing our answers in the second row of our answer matrix. So we're going to do -3 times -4, which is 12, always plus. 1 times -2 is -2. Second row times second column is going to be -3 times 4, which is -12, plus 1 times -4 is -4. Finished multiplying the second row times all the columns. So now we are going to go to the third row. So we're multiplying with the third row. That means we're writing our answers in the third row. So we're going to do third row times the first column. That's going to be -5 times -4, which is 20. Plus 1 times -2 is -2. And then third row times the last column is going to be -5 times 4, which is -20. Always plus. 1 times -4 is -4. And then I'm just going to double check my math on all of these real quickly. So I don't want to confuse anybody by making a careless mistake, which I've done so many times. Okay, so that looks right to me. And now I'm just going to clean this up. 0 plus -10 is going to give me -10. 0 plus -20 is going to give me -20. 12 plus -2 is going to give me +10. -12 and -4 is going to give me -16. 20 plus -2 is going to give me 18. And -20 plus -4 is going to give me -24. And that would be my answer. So let's kind of backtrack here. We added and subtracted. Probably one of the easiest things to do. Remember, when you're adding or subtracting, this one is subtraction, your dimensions have to be exactly the same. And then you just subtract the numbers that are in the same location in the matrix. Number 2 is an example of scalar multiplication. So this is not a matrix times another matrix. This is just where we have a number on the outside of the matrix, and we take that number, which is called scalar. We multiply it times everything inside the matrix, and we get our answer. Number 3 is an example of matrix multiplication, where we're taking one matrix and we're multiplying it by the other. I think this is one of the harder things that we do in Unit 8. And now to section 806, which is determinant. So I'm going to start with a formula for a 2 by 2 determinant. So let's look in the green box. So if we have a matrix A, and we'll just say that the elements of the matrix are A and B are in your first row, and C and D are in your second row. I use this example a lot when they give the definition. When we're finding the determinant, they're going to use these little vertical bars that look like absolute value bars, but they are not. And when we are referencing to a matrix, they mean find the determinant. So the determinant of A is going to be A times D. We always start in the upper left. That's going to be really important. So A times D is kind of like cross multiplying. We're going to do A times D. And then we're always going to subtract. That's confusing to some people. And then we're going to multiply B times C. So it's always, we start in the upper left. of our matrix, it's always A times D first, it's always subtract, and then it's B times C. So for example, if we're finding the determinant of this matrix, we always start with in the upper right, and we do 5 times 4, which is going to give us 20. We always subtract, and then we do 2 times 3, and then we simplify that. So there is a formula for finding the determinant of a 2 by 2. It's going to be A times D minus B times C, and then simplify. I think we've got another one. Again, we're finding the determinant of a 2 by 2. We know it's determinant. We know they're asking us to find the determinant because we're using these vertical bars, which when referring to a matrix means determinant. We always start in the upper left and we cross multiply. We multiply the numbers that are in the diagonal. You can say cross multiply if that makes sense to you. So we're going to do 3 times negative 2, which is going to give me negative 6. The formula says subtract. And then we're going to do 5 times negative 6, which gives me negative 30. So it's going to be 3 times negative 2, subtract 5 times negative 6. So that's really going to be negative 6 plus 30. So that's going to simplify to be 24. Not so bad. Be really, really careful with this minus sign. Okay, finding the determinant of a 3 by 3 is probably much more complicated. I don't know how your brain's going to accept this. It might go, oh, that's not so bad. I got it. Yeah. This was, to me, a pretty clear graphic, even though it's probably quite complicated. But when you have 3 rows and 3 columns, finding the determinant is going to be a little bit more complicated. So if you'll notice, this is A, P, and X. That's the first column. This is B, Q, and Y. That's the second column. This is C, R, and Z. This is the third column. And then all of a sudden they have some more columns here. So they have APX again. Then they have B, Q, and Y. And then they have C, R, and Z. I'm thinking for just a minute because I don't usually do it this way. So I'll tell you what I do is I don't use this one at all. And then I do AQZ plus BRX. So this is A times Q times Z. So you'll start in the top left and you'll multiply the numbers that are in the diagonal. Plus B times R times X plus C times P times Y. And then minus. And then what I do is I do minus this diagonal. This simplifies it a little bit more. I thought this is exactly the shortcut I do. This is a little bit different. I'm sure it still works, but I'm going to do it the way I was taught. So then you're going to start down here in the lower left, and you're going to multiply those together. You're going to subtract those. Then you're going to multiply Y times R times A minus, and then Z times P times B. Now, hopefully they're not going to ask you to find the determinant of a lot of 3 by 3s. But as soon as I say they're not going to make you, the OHS will probably put one of those in there. Okay, so let's take this formula, and I'm going to show you. So again, I'm going to change this up a little bit. So y'all just watch. I'm not going to put this column in here. And then this is going to be different. This is going to be minus XQ C minus YRA minus ZPB. Okay, so what I do first is I take these first 2 columns and I repeat them. So let me change my colors. So I take this first column, I go to the right of this vertical bar, and I repeat it, 1, 0, 1. I take this second column, and I go to the right of this first column that I repeated, and I repeat it. So the shortcut that somebody taught me a long time ago just uses these first 2 columns repeated. This shortcut uses the third column repeated, and so I'm just shortened this even shorter. So this is a shortcut to the shortcut. All right, we always start in the upper left. Even if it's a 2 by 2 determinant, we always start in the upper left. I think that helps me remember the path that I'm taking. So we start here. We multiply these three numbers together. So 1 times -1 times -3 is going to give me 3. And then I do plus. I go to the next diagonal. 2 times 4 times 1 is 8. Plus 3 times 0 is 0. Okay. Then we switch to minus. So now it's going to be minus, and then we go with the numbers this way in this diagonal. So 1 times -1 times 3 is -3. I'm just going to put a parentheses there since I have a minus and a negative. And then minus 0 times 4 times 1 is 0. Remember, if you have a 0 in your diagonal and you're multiplying, you're always going to get a product of 0. Minus -3 times 0 times 2 is 0. So this is going to be 3 times 3 plus 8 plus 0, which is 11. Minus a -3, which is going to be plus 3. And then this is going to be minus 0, minus 0. So that's going to simplify to be 14. We'll see if I have another one of those. I don't. I am going to just erase. Now, y'all can rewind and watch it again. If we were doing this live, I might erase this and I might show you the process again. So we start in the upper left. We multiply these numbers. We add. We multiply these numbers. We add. We multiply these numbers. We add. That's where I got the 3 plus 8 plus 0. Then we subtract. Then we go down in the bottom left, and then we travel this way in the diagonal. So 1 times -1 times 3 is -3. Subtract. We subtract on these last three. 0 times 4 times 1 is 0. Subtract. And then -3 times 0 times 2 is 0. And then we simplify that. Okay, 2 by 2s, a little bit easier. They have a formula, A times D minus B times C. If it's a 3 by 3 matrix, we're going to use the shortcut for the shortcut. And that's A times Q times Z plus B times R times X plus C times P times Y minus, and then you're going to multiply X times Q times C minus Y times R times A minus Z times P times B. And then simplify. All right, 8.07 is inverses of a 2 by 2. There is also a formula for that. So this is in this green box. Is the formula that I saw that I thought was the clearest way to explain how to find the inverse of a 2 by 2. Just a quick reminder that anytime you see something raised to the -1, another way to say that is the inverse of whatever is being raised to the -1. So this would be the inverse of A. So it's 1 over, this is the formula part. So the inverse of A equals 1 over A times D, minus B times C. And then we take the A and the D and we swap those two terms. And then we take the B and the C. If you'll notice, here they are in the original matrix. And these negatives mean we're changing the signs. We're taking the opposite. And then sometimes we take the scalar that is on the outside and multiply it in. Sometimes they leave it there. I'll show you in this first example. So they're asking us to find the inverse of A. So that's going to be following the formula. This first part is going to be 1 over. This is always your A, B, C, D. So we always start in the upper left. Multiply the numbers that are in the diagonal. 3 times 5 is 15. Always subtract. 0 times -1 is 0. Then we open up a new matrix. We take the numbers that are in the A and the D spot and we swap them. So the 5 is going to move to the top left. The 3 is going to move to the bottom right. And then we take the opposites of the numbers that are in the B and the C spot. So if you take the opposite of 0, you still get 0 because 0 is neither positive or negative. But if you take the opposite of -1, you get +1. And then we'll simplify the scalar on the outside. It's 1 over 15. Didn't mean to put equal there. And then we write our matrix. 5, 0, 1, 3. Sometimes they let you leave your answer like this. So I would just look at the answers if it's multiple choice. So it might be okay to leave it like this. Or this 1 over 15 is a scalar, so you can multiply it into everything. So 1 over 15 times 5 is 1/3. 1 over 15 times 0 is 0. 1 over 15 times 1 is 1 over 15. And then 1 over 15 times 3 is 1/5. So I can see both ways. So I would just kind of go with how the OHS has presented it, or if it's a multiple choice problem, look at those answers. I don't think you'll see both of these answers. I think you'll see one or the other. So this is finding the inverse of a 2 by 2. Let's do another one. So we're finding the inverse of matrix B. So that's going to be 1 over 2 times 3 is 6 minus 1 times 6 is 6. And I can stop here because I'm going to end up getting a 0 on the bottom. And down here it says, note that the inverse of A exists only when AD minus BC does not equal 0. So if you get a 0 in the bottom, 1 over 0, we know we can't divide by 0. So in this problem, the inverse of B is what we call undefined. That's only going to happen when you get a 0 on the bottom there, because we can't divide by 0. All right, got another one here, finding the inverse of matrix B. So the inverse of B is going to be 1 over negative 2 times 4 is negative 8. Follow the formula, subtract 3 times negative 7 is negative 21. We're going to take the A and the D and swap places. So 4 will come to the top left. Negative 2 will go to the bottom right. Those signs don't change. We're just swapping the locations of the terms. And then the B and the C will change signs. So the negative 7 will become positive, and the positive 3 will become negative. We'll simplify our scalar. So negative 8 minus a negative 21 is 13. So 1/13 will be our scalar, and then 4, 7, negative 3, negative 2. So again, we might see the answer written like this, or they might multiply that scalar in. So 1 over 13 times 4 is 4 over 13. 1 over 13 times 7 is 7 over 13. 1 over 13 times negative 3 is negative 3 over 13. 1 over 13 times negative 2 is negative 2 over 13. So I can see this either way. I don't think they're going to ask you to find the inverse of a 3 by 3. I can honestly say that's something I've never done by hand. A calculator might do it, but as far as them asking you to find the inverse of a 2 by 2, I think of a 3 by 3, I don't think they're going to go to a 3 by 3. I think they'll stay with a 2 by 2. All right, again, I apologize that I got called into ACAP makeup testing Monday, and I wanted to go ahead and record the lesson that I would have taught in Class Connect and whole group Monday at 12:45. I am going to send out this video along with a link to the whiteboard. I'll put it in the announcements, and then I will send it out by email. So if you've got some friends that are in the class that are going, oh, Miss Prater wasn't here, so, and you've listened to the video, you read the announcement, just say, hey, she had to be called out for testing, but she noticed a video. So share that with your classmates, and I will see you all soon. Bye.